Alright, so this is the last thing I want to talk about, which is how to measure biological age and also DNA methylation. So, if you measure the chemicals that control the packing and unpacking of the genome that specifies cell type, there are certain sites on the gene that you can measure. The chemical is specifically called DNA methylation. Let's think about that for a second more. So if you measure the chemicals that control the packaging and unpackaging of the genome that specifies cell type, there are certain sites on the gene that you can measure. So I believe whenever they say gene, that's also the same thing as DNA. So gene and DNA, kind of like the same thing. So I imagine that 6-foot DNA strand, there's certain sites on that DNA strand that you can measure. And the chemical that you're measuring is specifically called DNA methylation. And I remember Sinclair, he said it was super simple. DNA methylation is simply 1 carbon and 3 hydrogens. That's pretty cool. Cells add this chemical to DNA. It sticks to DNA as you're developing in the womb to make a brain cell different from a liver cell. So they have totally different patterns. The chemical on the DNA has totally different patterns. It was added while you're in the womb. That's interesting. So does it get added any other time? Like there's more I need to learn about that. Over time, there are changes to those chemicals that are predictable. They change in a linear fashion. So if I take your skin cell and measure DNA methylation pattern across the genome, which is the 6 feet of DNA. So if I measure that DNA methylation pattern in one cell, or in thousands of cells, which is probably even more accurate, I can then plug that into a program and it'll spit out your biological age. Which is so interesting. Because this DNA methylation changes in a linear fashion. So we can literally, and it's consistent across all cells in living organisms. So this means you can literally measure aging. Sorry, this is like hitting me again, like how cool that is. That is fascinating. I like it because it's like a computer program. Like when people talk, and they're like, "Do you understand this?" It's like, I mean, the words came out of your mouth. I don't know if I understand it, but this is like, it's like a math equation. I love it. I mean, there's still a lot missing here that I don't know about, but it's making a lot of sense in like kind of a mathematical way. So, yeah, they talked about how you can use DNA methylation to predict when you will die. And the other guy, what's the other guy's name? That guy. He basically said, "Isn't that terrifying?" But I agree with Sinclair that being able to predict when you will die is liberating, because now we can actually slow aging and we can reverse it, as we were talking about with metmorphin, which literally repackages the cells and teaches them, like, helps them relearn how to, do their job again. So yeah, we can get that DNA to unpackage less and even repackage to reverse aging. That is just extremely fascinating. Love this podcast. Excited to learn more about all of this. Hoping I can apply it to my own life.